some of the things that are a little different about Mainline as opposed to the yard and some of the other things that we've been talking about. We threw up this in the news thing mainly to just kind of identify some things that you know, that I guess from my point of view, a lot of the the trade magazines, it is important, beneficial to kind of keep up, just glance through what's going on, what's the trends in the business, what are some of the things that are happening, and does it directly impact what we're doing? Chances are it most of the time it doesn't, but it keeps you in tune with the changing things in the marketplace, and some of the new things that people are considering, and also in the thing that we popped up here was just a freight car, U.S. freight car fleet, and you can see some of the cars, just look at a plain box car, that used to be kind of like the mainstay of the railroad industry, and over the last couple decades, almost there's relatively speaking, there's getting few and less of the regular box cars. A lot of the cars are being, the car fleet is directed towards intermodal. The past couple of years until the recent downturn, they're looking at tanker cars and moving oil by rail instead of pipeline, because they can get to, by rail you can get to more locations, and it's in an infrastructure that's already there. But the important thing there is just to kind of understand what are the trends and where the industry is going, just to kind of keep in tune, have a conversation, be able to participate in the conversation with the people that you're working with. It's always a good thing. We're going to look at in this section is mainline capacity improvements and how them are different from what we have been talking about in the past, and then also what are some of the critical things that we're going to want to consider when we get out of the main line. It's surprisingly, we kind of ebb and flow to the kind of business we have. Some people spend their whole career just working on industrial track stuff. Some of us, like here in Chicago, we've been doing the majority, not all, but the majority, probably about 75%, has been intermodal related. And then somebody else will be just doing capacity improvements and never set foot in the yard. What we want to talk about is, highlight some of the differences between the main line and then, the different yard track, is how are we going to design that? What are the things that we're going to have to pay attention to? Some of the things, railroading is still railroading. How do you apply that? It's just a lot different than what, when you're going 5 or 10 miles an hour than if you're going to go 60 or 70. Some of the issues that you run across are different. We get more involved with super elevation and those types of things. We worry about grade crossing improvements and capacity issues. And what is that design, process? How is that different? A lot of times the railroad guys will be different that we're dealing with. The guys out in the main line, everything is supposed to, be is where all the action, all the fast action occurs in the yards. Things are slowing down. That's where you really lose time. I worked, started my career on a railroad that, I think in a lot of ways was really cutting edge, but then in others it was a bankrupt railroad. We're going through that period when they were downsizing the railroad industries, and it was, we had a situation where, we had a hard time getting our trains over our main line, and we couldn't, our trains weren't running 60 and 70 miles an hour. They were generally running about 30, and, by a naive guy, I was asking one of our operating guys, how can we compete? We had one situation where our train left Kansas City 12 hours behind time, went over on the Santa Fe to get to Chicago, and actually arrived ahead of schedule. So my first reaction was, how do we compete against another railroad that can, smoke us that bad on a, on mainline operation? And the way it was because, we did yard operations still, real well. And it was not so much on how fast you got something to where you're doing. That was part of the thing, but it was when you got there, and it was more, more important that you got it there when you said you were going to than get it there. If we said we're going to get it in 3 days and we got it there in 3 days, that was a lot better. Some of the other railroads were, they'd run and hurry up and get their trains to the yard, and then they still didn't get it to the customers fast enough. So we could still compete. So there's just a different mindset and different things. We want to identify the key elements of the mainline operations, and like I was saying, it is a little different. That whole mindset has to change. The types of projects that we're going to get into are capacity projects, siding extensions, new sidings, and then extending existing ones, double and triple track expansions, operational improvements. You might just add a crossover so I can get to this track easier than I could before. We're going to the whole premise or thing that we're trying to shoot for is to be able to operate the railroad at a faster pace. Not a whole lot unlike on a highway when you got a fender bender in the in the other lanes, in the other direction. The traffic in your lane starts slowing down. You're wondering why that happens. The important thing is that everything is fluid. So that's one of the main criteria on the mainline operation. Don't encumber the trains, making sure that they can go as fast as they can. The faster you go, the more capacity the line has. We're going to look at new lines, build-ins to industries. A lot of times you'll have a coal mine or some power plant. They don't build it on your railroad or on one given railroad. They want to, in a lot of cases, what has happened is I'm served by the BNSF, for instance. I'm a coal plant, power plant that's served by the BNSF, and I'll get better rates if I'm also served by the UP, and build into that power plant. Those are some of the types of projects that you might get involved in. Shoe flies around bridges. How do you replace a mainline bridge while you're working on it? That might take you, 3 months to build the bridge, and you can't take the track out of service for 3 months, so you have to build a shoe fly. So it's just basically a bypass around there. Deal with passenger stations, drainage improvements, and the main thing that you're trying to do there is make sure that the track is stable, and so you don't have to slow order. If you have a lot of drainage problems, the track doesn't keep its surface in line as well, so the speed has to slow down. We mentioned on the shoe flies, bridge construction, so we'll be involved in that. What do we have to do? We'll be involved, that might not design the bridge, but one of the things that's usually the case is most bridges are actually the low spot. They're, where a waterway is across the railroad. That's where a lot of the bridges are. Obviously, some of them are grade separations with highways. But when they're the low spot, usually where the creek crosses, that's the low spot in the railroad. It's over the years, the railroad has surfaced the track, and which actually makes that the lowest spot even more so on the railroad, because they keep running off into the bridge. They don't really often raise it because it takes a little more effort. So one of the things that when a bridge is being replaced, one of the things that needs to be done often is to correct that line, try to get that little hole out of the profile. Things you want to take into account. And sometimes clearance projects. One of the things that the CSX and NS is doing on the East Coast is making sure that they can get double stack containers into all of their intermodal facilities. On the Western railroads, it's almost taken for granted, not even a concern. But on the East Coast railroads, trying to get into some of these locations is very difficult. Sometimes it's old bridges, Sometimes it's historic bridges, sometimes it's in very congested areas that clearances really can't be alleviated to any great extent, or without, I guess, anything's possible with enough time and money. You can pretty much do anything, but clearance projects are a major issue on the Eastern railroads. Common capacity improvement. Make it. You start running longer trains. You need longer sidings. Double tracking. One of the things that the UP and the BNSF, a race for the Transcontinental Railroad, was to see who could get, to the furthest, the quickest. Right now, they're in a similar battle, trying to making sure that they have their main routes are double tracked and eliminate all the single tracks. There's a lot of places in canyons and in the mountains and in other locations that the main line goes down. It's double tracked from the majority of the area, but because of these costly locations, costly to build another track, they get these choke points where they have to go from the two double track railroad down to a single, so they have to wait for somebody else to come in the other direction. The double track railroad allows you to run trains. Most of our trains in the United States run right-handed. They run them just like on the highway. You run down the right side, and in the other direction you come back on the other side. In single track areas, you have to build sidings. You have to make the sidings long enough to handle the longest train that you're going to want to put in the siding, depending on what size that is. With the track, to increase the capacity of the line, a lot of times they'll run longer trains. That way they can, one, it's less locomotives per train, per rail car, per ton. They also can get by with less crews. So they try to lengthen the trains when they can, but when they do that, and especially if you're on a single track railroad, you have to have some place where you can put them trains in a siding. So that's one of the key things that we generally will be doing with capacity projects. Speed improvement. Speed equals capacity. As I mentioned, you increase the speed, you can put more trains on the track. So how you do that? Curves are generally one of the main things. The curve restrictions, so the trains can go around them a little bit faster. You want to flatten out the curve. Sometimes that requires a new grade, new property. You can also want to reduce grades on a railroad. Anything that's over, on our railroad, anything that was over 1.6% was considered mountain grade. And if it's very long, it takes, you have to add a lot of power to that. If the trains are restricted in length, with the steeper grades, there's a lot of places that over the years they've found another location, might have been a single track up a steep grade. They would bring another one, another route. So instead of going up the hill, they would kind of double track that railroad and make a flatter thing. Instead of going up the hill, and make the track longer, so the profile was better. And they could still use the existing main, but run the trains downhill, because the trains weren't restricted going downhill. They are to some degree to make sure you can be able to stop, but not quite as the same as going up the hill. We're going to look at the clearance projects that I mentioned, signal improvements to increase the flow on the line, line relocations. Sometimes that's just to get outside of, from some kind of development. A lot of railroads are now in the center of town. They were on the outskirts of town, but the town has kind of swallowed them up. Initially, they wanted to be downtown. Now they prefer to go around the outside. People want to get them away, so sometimes we get line improvements like that. Sometimes you shorten the route, add a tunnel. A little bit more not common, but something that you have to look at. So one of the first things that we want to look at is what are some of the things that we're going to have to do to as we get on the main line. And this isn't a whole lot different than if we're working in a yard or any other projects. If we're working on highway projects, you have to go out there collect the data, get the existing conditions, and some of the things that we're going to look at is survey, the importance of geotechnical investigation, looking at val maps. What are some of the sources of information that you can get from the railroad, and how valuable is it? Valuation maps are generally the maps that sometimes they're referred to val maps, other times right-of-way maps, but basically they include all the railroad and the property lines of the railroad, so you can get a pretty good idea of what the railroad owns and the alignment characteristics. We'll look at track charts as an example. We'll talk about them when we get there. Conceptual plans, the importance of site visits, interviews with local personnel. The BNSF, for one, has that in all their things, is to try to get a historical information from, try to interview a roadmaster. What are some of the problems? Do they have slide issues? Do they have track surface issues in that area? So something that, if you're going to make some improvements, that you can address them. You want to understand what the long-range plans are for the track. We'll talk a little bit about, ruling grade. That's the maximum on a given subdivision. That's usually the ruling grade. It's the controlling grade. So they just size provide enough power to the locomotive or to the train to be able to climb that hill. Like I say, the real steep hills are somewhere between 1.5% and 2%. Very rarely in the United States do you have main lines that are over 2%. There are a few locations, but industry tracks, you'll have lots of short little pieces that allow you to go up to 2% or 2.5%. But on the main line, it'd be very unlikely to have much over, very much, even in the mountains, to go over 2%. And then you're going to want to pay attention to, what's going to happen outside the railroad, what kind of development is happening in the area, what kind of grade crossings might happen in the future, to where you understand that and can add that into the design criteria when you evaluate the project. So we're going to try to take a look at the existing conditions, and it's, like I say, this isn't any different than doing any other survey. You want to identify what items are out on the track. In this picture, you got over on the right here, you got a propane tank. You got some light poles around these crossovers that they help to see. Hot air blowers. What can you do on different track conditions? If you're going to start putting more tracks in here somewhere, what are the track centers? You want to get a good sense of what's the situation out there, and be able to put that on your eye. So it's going to start off with that survey. One of the other things, you have to get to all these things. So access is becoming more and more. The more the railroads run trains, it's harder and harder to get on there. You used to be able to go out there with a motor car, which is, and now you get out there with a high rail, but most of the time you can't get permission to get on the railroad, so you want to be able to drive there so that you can maximize the amount of time that the trains aren't operating over the line. You're going to want to take a look at clearances. Here's just a location, and one of the things, a lot of times you walk along the railroad, you walk right underneath the bridge. It's not in the middle, there, but you don't look at the vertical clearance. The majority of our challenges and things that are hard to, that we have to solve are on the vertical plane. Horizontally, everybody kind of sees what happens there, especially when you're drawing on a plan. Everybody sees the plan, but without knowledge or understanding of the vertical components, we a lot of times come up to the wrong conclusion. And one of those is checking on see what the vertical clearance. And I believe that this one's kind of, sloping in one direction. So if for something, your project was going to be putting in a new main line or a new siding over here, sometimes just because it's clear over the main line may not be clear over on the side. So you want to get a good understanding of what that, you want to be, what is the vertical clearance. When you're out there, you want to also say, vertical things like wire crossing. As silly as it sounds, you can walk underneath a, railroad bridge and forget to have the surveyors check that. But it's a lot easier even to do that on a, on a power line crossing that you can barely, you hardly see because you're looking at the poles are off the right of way, so you just kind of get the conclusion that there's no obstacles out there and you forgot to look up. Again, you want to identify, all the components, for a couple of reasons. One, if does this thing have to stay there? Does it need to be renewed? Does it look like it's, an old style that somebody, may want to replace? If we're going to do a lot of work, because a lot of times if a piece of equipment is, has reached its near its useful life, you may want to increase or improve that with some of the current technology. This happens to be a rail lubricator that puts grease actually on the track to help them go around, in this case here, the curve that's up here, so they do less wear. But you want to identify what those are and what impacts they might have on your design. Through this one out here, you want to look at stuff, we got the signals. Everybody might look at the signal stuff, but these are AEI readers. They read the numbers on the cars. That's something that's actually handled by the communications departments on the railroad. A lot of times people will bring in the signal guys, but then they forget the telecom guys. The signal guys, well, that's not my thing. But if we see them out there, even if we don't know what they are, we need to identify those and get the right folks involved. If we're going to make any track changes or add a track, we're going to have to address those. What you have here, just some terminology. You got a cantilever signal, signal bungalows, a wayside signal. Here's near a passenger platform. This can be considered a high platform. Generally, it'll go off into the car floor of the commuter railroad. It's always nice just to take a good glance, take some pictures, take an inspection. Even if you're not a railroad guy, you can see that track isn't very well surfaced. And if you're going to do some work in this area, that may be considered something that you may want to address. This is a signal bridge. Generally, it goes from one side to the other. Consequently, that's called a bridge. One of the other things that's real important is our site visits. And identify. We're doing the main line, but if we're going to put another track in out here as one of the parts of this project, we may have to remove some of this track. A lot of times what the railroad has done is they've only removed stuff in the past to the bare minimum to get by. That was particularly true, on a railroad like I belong to that was bankrupt. So they didn't do any more work, than they had to. As part of our plan set, we want to understand what that is. We want to make sure we get the survey information here of this. But then also we got a couple of rails that are in there, but we also got some extra materials. This is probably a turnout, what's left of a turnout. So you may want to, this track probably goes back here in the trees. It probably goes in here. Sometimes it's buried. But the importance to our plans is that it costs money. A lot of times ties are a hazardous material, or at least it's a special waste. The railroad will handle that different. Sometimes the railroads will even handle the track removal by somebody else nowadays, but they generally don't leave the ties on the right of way, so they have to deal with removing them. Other special things that you might run into, we have this situation where we took a picture of this, which was, we didn't know it was some kind of a grave. We assumed at the time that is probably somebody's pet, or it might just be a memorial for maybe some kid was walking on the track and got hit there, and they had that. But it turned out to be just they buried the pets. They didn't want to do it on their property, so they went over on the railroad. But the important thing was that this was a grave or something that the survey folks need to pick that up. And that just shows why you do that site visit, you take some pictures, and try to convey that to the surveyors to make sure that all that stuff is picked up. On that photo log, it's really important. One of the things that we've been doing, and we found it very helpful, is doing it in a PowerPoint slide. One, you can usually have good quality photos. It's easy to label, and you can do a lot of kind of things in here. And here's somebody who just made a point that this is actually Cooper Road, south of the BNSF, at the Hinkey property. But then showing that this one of the lines stops right there and it feeds Hinkey farmhouse here. We just happen to know that. But it's them little things that you want to know that, if we have to adjust this power line for some reason, we'd be able to, know that, and kind of flag that extra work. Here's another, label the PDF. And what they did here was label the bridge. One of my problems, I take a whole bunch of pictures, but then, even though I took them, sometimes I forget what they are. And even if I don't forget it, the guys that bring it back into the office, they don't understand. And here, this uses the railroad's nomenclature. Know what bridge it is, which way you're looking then. It adds a lot to that photo log. Another thing that you want to, identify, we're looking to south, and it's amazing when you're out there taking shots. After a while, you start, unless you have some landmark in the back, you don't know if I'm looking south on this, looking north. It's also helpful to put a note on the new siding is supposed to go over here, so you can kind of identify that. You can try to put a milepost, so now you can a little clearer there. You've got these are old signal foundations. Not a major deal, but if you're going to put another track in there, you're going to have to remove them. Identify what they are. They're not, what's above the ground is pretty minor, but what's below the ground is pretty substantial. So you want to identify that and be able to convey that on a drawing. One of the other things when you get that survey is to go out there and take a look and check that survey. We did one where the culverts, we got the inverts, the water runs downhill, but what we found was the actual culvert, was back pitched. The water actually ran the other way, so we came to a different conclusion, based on the survey than when we went out there and looked at it. This picture here, this is a retaining wall, or so that, it's a remnants of a retaining wall. But on the survey data we got back from the survey, it said this is a retaining wall. Well, I guess it just shows here that you have to be a little more explicit because, I don't think any of us was really, it's uncomfortable to call that a retaining wall, but we envision some kind of concrete retaining wall, easily, maintained and whatnot. And we find out here that, it's a bunch of ties that, have basically disintegrated and are, for the most part, are no longer doing what they're, pretty much not doing what they're doing. And, it's something that's extremely important for us to understand. Again, identifying the signal bungalows, locating the crossovers, where the signals are, where the right-of-way fences are. This happened to be where that retaining wall in the previous picture was just down below this. So you want to, go out there and make sure that you understand what the situation is out there. Where there's fences, where aren't fences, and what impact you have. Here building a new railroad along here. What is the situation, with that fence? and this happens to be an existing retaining wall that is actually a concrete one. So you want to have a pretty good idea, and a lot of times pictures and site visits will help clarify some of those things for you. You want to try to identify constraints. One of the things that was happening here was we were going to put a new main line over here, and for the most part you had plenty of room, but here's a cantilevered signal that went across. There's actually 2 tracks over here, and just being able to tell that, moving this thing out so you could put another track in pretty much close to where all these guys are standing. There are some obstacles, and a lot of times we can all read the contours, we can look at spot elevations, but get a couple of pictures, it just jumps right out. You have to, okay, moving that thing out another 10 feet probably isn't going to be as easy as somebody that's not paying attention might think. You have a couple of things you want to appreciate that, the situation. Is this just a dirt cut? It happens to be rock. If you're going to we're going to try to put another track in here. And obviously, if it's rock, it's a lot different than if it's dirt. Making sure that the surveyors identify that, you identify it on the track. This is a milepost. A different way of doing that. Find out what those things are, and try to understand. You're going to want to take a look. What kind of drainage are there? Not much of a track ditch here, so what kind of drainage situation do you have? Is there potential drainage problems? You walk out on the railroad on a nice dry day, then it's been dry for several weeks. The railroad looks a lot better, but try to envision what the situation looks like, and on that rainy day, and sometimes you want to get out there on right after a rain or during a rain and find out what the situation is, so you can appreciate the situation. And one of the other things, it has nothing to do with the railroad, but this happens to be right where we're putting a siding. And not only was it a debris area, it started asking some of those questions, like the local guys, well, they use this as a dump. There's this road out here that's kind of separated. The main road is actually on the other side of these houses, but it made it real clean for people to just drive up here and just throw crap over the fence. And what we're trying to do is put it, extend this siding down through here, so people are going to dump on there, and if we're going to have a track there, what kind of ramifications are there? So what we proposed and what the railroad wanted to do was put in they put a fence in here just to make it that much harder for people to dump garbage there. So them are the things that are part of the job that you have, but being able to, that site visit, being able to ascertain what the issues are is just something that you can resolve. Another thing that you're going to want to make sure that you understand is the geotech. Do you have bad soil, good soil? In this situation, all this gray stuff here, that's rock. So we're cutting in some of this, in cases that we were, at a 40-foot cut here, and half of that was going to be rock. Even if we took your normal, this one we took more because we knew we were going to go down, but a lot of times your borings are only 10 feet deep or something. Everything looks fine there, and you find out that you had rock or doing, so you're going to want to understand that. Sometimes the geotech are familiar enough with the situation. You can talk to the local, roadmaster, and that they can have a pretty good idea how deep rock is. A lot of ways to tell that, but the geotech investigation is one of the main reasons that you're going to do that. You're going to want to try to put the the profile of what you're trying to do, so you can identify what the issues are. There's a cross section, and what we did was, your first thing was we took borings around where the track was, and found out that the rock was going to be fairly shallow. So one of the things that caused the problem is, which way does the rock go? If we knew the rock was going to be halfway here, it was 20 feet deep, did the rock go this way? So where this might actually go out of the ground, or was it level or not? So what we had to do was take some shots outside of where our cut was to try the best that we could to get what that plane was, try to identify. When you start removing this much rock, underneath the railroad, it gets fairly expensive. So again, the more expensive the potential, same way with, if you're trying to go through a peat bog, railroad don't work so good in a peat bog, so you have to try to find out how deep is the soil that you're going to have to remediate. Another thing that you want to look at is we mentioned data collection regarding a track chart. It's a little hard to read on here, but some of these track charts, each railroad does it a little different, but you end up with a lot of information. You got the grade. Sometimes some of the railroads give you approximate, elevation of the thing. I wouldn't ever use this to design my track, but it gives you a good idea of which way the track is. We had a situation on the UP that a developer had to develop a site, and we were just using Google Earth, and they thought they were out there on the site, oh, it's real flat. Well, when we were out there just moving our cursor over on Google Earth, we found out there's about 300 feet difference from one end of the yard to the other, which right next to the railroad. And then when in this case the client was saying, well, we were out there and it's flat, it can't be right, or it can't be wrong. Well, then we got the railroad's track chart, and it showed that it was a 2% grade. And like I said before, you very rarely find a 2% grade on a Class 1 railroad's main line, and there it was. That kind of confirmed. So, Mr. Developer, you got more of a problem here. When you thought it was flat, your 8,000-foot tracks are, and we ended up, when we did the grading models for, just kind of even the conceptual stage, we were talking about 30 million yards of dirt, and it was difficult to, overcome those grades even at that. So we're going to have to fill, 30 million yards of dirt, and where are you going to get that kind of dirt? It'll also tell you that, the alignments, what kind of curvature you have. It'll also identify, where the signals are. Sometimes they're up to date, sometimes they're not, but they're a good first shot. It shows you where you got parallel tracks and, potentially a yard here, so you get a pretty good understanding. Sometimes it'll give you how much traffic, how many gross tons. That's not always the case. It'll give you the maintenance, tie-in surfacing in October of 2002. Some of them will actually say that the rail was, what weight the rail was and what was relayed. This has some kind of a code. I'm not sure what it is, but usually a track, one of these track charts has abbreviations and legends to identify that. It identifies a grade crossing, railroad structures, either if they're grade separation in some of these cases, or drainage structures. It tells you most of the time what kind of a structure it is. So if you're going to have to extend it or relocate it or build another one adjacent to it, you can get a lot of information from a track chart. You can also identify where the crossovers are. So I have a crossover here. So if you're going to have to do something that, for staging, how far does the train have to, go before it can cross over to the other track and run around my work area? There's a lot of stuff that you can learn from the track chart, so you want to get them as quick as you can from the railroad. Another, that came up before, that's interesting. Same thing, but these val maps, it identifies what town it is. It gives the curvature. It identifies, sometimes it'll identify the city limits. It'll give you the county limits a lot of times. So if if you're working in we had one where it's split between the Rock Island District and the Chicago Core District. One of the ways we found that out is is, we kind of knew there was something. We knew the core district in Chicago handles East County. The drawing just similar, like this one was between two different towns, but it showed the county line there, so we knew that we went into a different county, which was handled by the Rock Island District. Most of these will give you the data on, who owned the property and when, so you can sometimes find the deeds. If something where you're going to try to swap property, you can get the railroad involved, but a lot of times the deeds, a lot of railroad stuff, it reverts to the adjacent property owner when you sell. So you always want to try to identify. These things will also, most times, will identify pipeline crossings or aerial, power line that goes across. You can find out the agreement number, and then the railroad can trace that down and find out what kind of rights you have or what rights they have. So one of the things, based on all that, after we get our survey, why the survey is happening, we're going to try to set up, our design considerations. What is that design criteria that we're going to design to? Differences between passenger and freight. They're both going to be worrying about safety. Passenger is going to be more time sensitive. Delays might be not as tolerable. They still want on-time delivery, so they don't want any, the freight trains want to be, under control. You're going to worry about, same, everybody's going to worry about speed, but you're going to, the passengers are going to worry about rider comfort. You want to go fast, but you also want to make it comfortable for the passengers. You want to keep the line moving. You're going to get noise and vibration for the passengers. Worry about, what kind of noise. You ride the CTA, for instance, here in Chicago, and it's really noisy. That's something that they haven't really concerned themselves, but it's one of them things that when you start riding transit things in other cities, you kind of, whoa, it's not, it's very, it's quiet, it's all, a lot more comfortable. But the CTA, much of which is over 100 years old, wasn't quite designed to those standards, and they haven't made any changes. But you're going to try to identify what kind of equipment's going to be used, what is the purpose of the line, and a lot of times in our, you got to, where we deal with passenger trains, even if we're dealing with just freight railroad, is that Amtrak may be running on it, and we might have to consider that as part of our design criteria. But you want to try to identify that and document what's going to happen and what you're being asked to do. It's an extremely important step in the process. What are the, I don't know how we got in the news thing you got in there. I guess that was supposed to have been earlier, but it just I think we got this in the wrong place. But anyway, you're just another indication of the changes in, crude oil by rail. There's hardly none of that occurring in 2005, up through 2014. It continued the skyrocketing thing until last year. Everything kind of fell out. That's one of the reasons the railroads are slowing down. But some of the things just to kind of keep tabs on, on the business in general. But anyway, sorry, we're a little digressing there. On the design criteria, one of the important things is what's the design speed. We also want to understand what is the design speed and what is the likely speed. There's a lot of things that happen that affect the speed. That we want to run that's this subdivision from point A to point B. The railroad wants to run 60 miles an hour through there. And so consequently, you'll design everything in that subdivision will be designed for 60 miles an hour. But if something happens and you can't quite make that, if you're out in the middle of the line, 60 miles an hour is pretty critical. You don't want to slow the trains down after they get started. But if you're at the, at the beginning, and you find out that all the trains stop at point A because they get new crews, they might have to fuel the locomotives or whatever. If you have to, if there's something that is major expense to get 60 miles an hour right outside of that town, it may not be worth the effort. So you may want to say that 30-mile-an-hour design there for the first couple miles may have some benefit there. You don't want to spend, multiple millions of dollars to try to improve and get 60 mile an hour, and the trains will never see 25 ever because of some other constriction or constraint. The other thing, you always want to caution yourself on that is because you don't want to identify or put some restriction, some future restriction based on the current conditions. So you want to always have that big picture, but you want to use all that information as you develop the criteria in your design to make sure that you accommodate what you're doing. What are the number of trains? What is the capacity? Again, if you get a lot of trains, we had something where we're with an operating guy with the railroad, and they had some problem. One of their trains lost, an air hose broke, so the train went into emergency and it stopped out on the main line. They had to get it started. So he had one train that was delayed, but because that line had so much capacity, so much traffic on it, it started backing. And this happened just out in Indiana, just outside of Chicago, and it started backing. They were saying that there was trains backed up in Cleveland based on, because they couldn't, their headways and stuff. It was impacting train traffic all the way across the country. So you want to figure out how many. On one of the lines that we work on, the BNSF, they call it Transcon, and quite frankly, they don't want any more business on that line. The people that run the train, you got too much business on here. Any train that comes in and onto that line just slows things down and hurts our capacity. So they don't really want, there's some people that want it, that their job is to get more business for the railroad, but the guys that run the trains between points A and B, they don't want any more traffic. So you're trying to have an understanding of all that is extremely important. You want to understand the mix of traffic, and the reason that's important is a coal train might, its maximum speed might be 45 miles an hour. A passenger train or an intermodal train, that maximum speed might be 79 or 79 or 70, and they're going. What will happen is that they will catch that freight train all the time, and then consequently they have to run around it somehow, but it restricts the amount of capacity that you have on that line. So you want to try to identify that and understand that as you're developing your criteria. You want to understand what track standards to apply. Is one of the, and I guess I'd qualify that, if you're on the BNSF, you're going to try to use BNSF standard. One of the things that we found in the Transcon in the Chicago division, they had different criteria that they, the division engineer had enough, clout or decision-making process that, all the crossovers on the Transcon in the Chicago division had to be number 24. But that wasn't a written criteria on the BNSF as a whole, but just in this thing. So you want to try to identify and apply the right standards. Obviously, you do it to the railroad, but there might be unwritten ones. So you're going to be, quizzing the people that you're working for to understand that. Capacities, we talked about that, double track, siding lengths. What is the current need? What is the future need? You may understand that because we've done a lot of sidings, and what happened is that they identified we want, our standard is for 10,000-foot sidings. On this given line, they're never going to run any trains more than 7,000 feet. It was their standard because, again, you never know what's going to happen in the future. But we had a major conflict is, and we had to build another bridge and go across a grade crossing, and it got to be a lot of cost to get that 10,000 feet. Well, if their trains are never going to be over 7,000 feet, for the foreseeable future, it was a branch line. They never projected it to be much longer than that. that, okay, so that decision was easily made that says, okay, we want 10,000 feet, but in this situation, 9,500 or might have even went down to 9,000 feet was more than enough. It would serve our needs well into the future. If for some other, reason that we needed our 10,000 foot, then we would pay that extra several $1 million to replace that bridge or to add a bridge and do all the grade crossing signal improvements, grades, and there's a lot of things involved, other things than just, the signals, but they would do that sometime in the future, and that was the decision, but it was based on, good knowledge of what we had. The other thing is what are the switching, conditions or needs in that area. Sometimes you might need a tail track out of, or a siding out of the extra length siding because they're not going to let you on the main line to switch that yard. You have to understand all that thing. And one of my overriding things is, and we just had a conversation internally with our group this morning, is that a lot of times the railroads tell you what to do. Well, sometimes they're wrong, and it's real sensitive on how we go about doing that. But I think they're looking for us is to try to help them do the right thing, so we can play the devil's advocate. Have you thought about this? What about this? You don't want to be in a position where, I think you're wrong. You want to do this, but just try to help them out to make sure that they've considered the situation. In a lot of cases, even our younger folks have more experience than the people we're working for in the railroad. In a lot of cases, not ultimately, but some of the people that we're actually dealing with may or may not have much experience. So it even becomes more of an issue. Don't do exactly what the railroad says, just blindly. Always be thinking of what they asked me makes sense, and makes sense in the big picture of all these things that we're talking about here, trying to set up that design criteria. What are we trying to accomplish? One of the chief engineers says, I can get a lot of people that can, do the engineering for me, but the important thing, I need somebody to understand what we're trying to accomplish. And there's a lot of different ways to skin that cat, come up with the right plan, but we want to be able to identify what is the most optimal option in those areas. Again, what is the train speeds? What it's going to have a need for the crossovers? Where do we want that? Is not having a grade crossing, is that imperative or a desired? So if it is, what is it relatively inexpensive to relocate that grade crossing or make it a grade separation? Is that what's required? You want to look at property acquisition. We've done some things as environmental things and permitting issues. Boy, we can't do that. Let's put the thing over here because we can get what we want, but we don't have that time frame. We'd rather have it here, but we need to have it this year. If we do that, we're going to have to go through a protracted property acquisition, a prolonged permit process. So we might as well build it here because we need that. We have a need right now for that siding, so we'll put it here and not there. To try to identify that. What are the utilities? Can the utility make them relocations that we want? Is it necessary? And then try to find out what that agreement. There's been some situations where a major power company has a major transmission line on the railroad's property, and you need it moved. Well, the agreement says that if you want it moved, if it's in your right-of-way, the utility has 30 days to remove it, and it's all at their expense. The next time, depending on what they paid originally for that easement, they might have a situation. You can tell me to move it anytime you want, but it's going to be at your, the railroad's expense. So that don't necessarily, change, where the alignment's going to go, but it certainly changes, what's the projected cost of the project, or the timing that might be required. Then always get in touch. Make sure that the the signal guys are involved early on. We'll go over some of the signal things that we want to take a look at, but that's going to be one of our critical things. Just looking, we're about out. We're intended. I think we'll continue on with this next week, and I'm thinking that I think we'll just try to quick go through a couple of different, just a couple of more here. But what, so just kind of summary of that basic initial first step, we're going to try to identify what the design criteria, what's the speeds to the curb, are we going to need any, detention requirements? That's something that the railroads never thought about in the past. If we're going to need permitting, from some local agency for whatever reason that is, because this was here as a build-in to a thing, so it was on property, not along the main line. The main line, the railroad has a little bit more, control. It's a national thing, but so sometimes we're not putting detention here. They require detention. What are the utilities that we're crossing? We got some utilities. We had some major pipelines that we had to deal with. In this case, they want an inspection road on, this is a switching lead coming into a yard. These are the main leads coming in. This is a switching lead, but for maintenance and other reasons, through this area, through the area where this switching lead or siding was, they wanted inspection tracks on both inspection roads or access roads on both sides of the railroad. So obviously that's going to impact the cross-section that you're providing. So that's one of them criteria that you're going to need. What is them side slopes? 2 to 1, 3 to 1. What does the geotech tell you? What are the impacts of property acquisition? And here's a case where we had a railroad crossing. That was something that they were able to close. It wasn't important. They were able to bypass the access route, and instead of building some kind of grade crossing here and doing all kinds of stuff, they built a grade separation down here and closed this crossing. So that's some of the things that you want to be looking at when you're trying to get rid of crossings and developing the railroad. So things to consider. We've talked about, just in summary, the track speed. What is the desired speed? Are the inspection roads required? Side slopes, 2 to 1, 3 to 1, or does the geotech say they have to be something different? If we can't, because we're trying to save property, save acquisition, maybe we have to make them steeper than 2 to 1. And if they're steeper than 2 to 1, do we have to do some kind of slope stabilization, riprap or a retaining wall to do that? Drainage and detention. If we're going to extend culverts, that's something. Don't always assume that you can just extend culverts. It seems to be the logical thing. Most of the railroad guys, okay, that's good. One of the things that the UP is doing in almost all of theirs is, chances are, because of development over the last 50 years, that culvert was sized when it was still farmland. Now it's built up city, and there's a lot more water, a lot more runoff that will go through that. So it's greatly undersized. It's just what's happened over the years. So instead of extending it, which would make the capacity even less of that pipe, the railroad has been trying to improve all of those, and in a lot of cases, jacking more pipes through. So instead of having a 36-inch pipe, now they got 260s because that's what it required, to extend it in the future. So they want to do it right from that. So you want to understand that. Check the floodplain. Are you in a floodplain? Are you going to need compensatory storage? What are the things that you want to have? Identify when you're doing that survey. Locate the existing signals. Identify insulated joints. We talked a little bit about them when we were talking about special track work. Trying to identify where those are is important on the survey. And identify the track centers. And then how to establish. We're going to talk about. We'll start off next week about getting a little more detail. How do we set that alignment of that adjacent track? But we're going to want to try to identify what them track centers, and we'll talk a little bit more about that next week. So that's our hour. Does anybody have any questions or anything they want to add or inquire about? Otherwise, we'll continue on with the Mainline same time next week. Any questions? We will take that as a no, and thank you for participating.